Good morning. This is the notes for Math 112 for Friday, November 3rd. The learning target for today is I can solve systems of equations. Let's remember what a system of equations is. It is a collection of equations that you're trying to solve at one time. Okay, today we're going to look at when you have two variables and then multiple variables, like three variables in a problem. So we are on page 1 of your notes. You got these the other day. And after the test on Thursday, we did 1 and 3. Well, let's look at 2 and 4. And right now, I would like for you to pause the video and work number 2 and 4 out. And then we will continue to make sure you're on the right track for 2 and 4. So pause the video now and work number 2 and 4 on page 1. Alright, so let's look at number 2. We have 1.5x plus 2y equals 20, and we have 2.5x minus 5y equals negative 25. Okay? Yes, this has got decimals in it, and then we got some whole numbers, so I got to decide which variable I would like to eliminate. Do I want to eliminate my x's or my y's? Well, I would pick the y's since you're working with whole numbers there. And then I think, okay, 2 and 5. What number can they both go into? Well, 10. Well, I'm going to multiply the top one by 5 for this to be 10. Multiply the bottom by 2, so this will be negative 10. So I'm going to multiply this by 5, this by 2. 5 times 1.5 is 7.5x. 5 times 2 is 10y. 5 times 20 is 100. 2 times 2.5 is 5x minus 10y equals negative 50. Remember, this process is called elimination because you're eliminating a variable. Now you got 7.5 plus 5. That gives you 12.5x equals 50. Then divide by 12.5. and x equals 4. Your solution to a system equation will be in the form of an ordered pair. Where this is just the x coordinate, we need to find the y coordinate. So you go back to your original, one of the original, I'm going to choose the top one, 1.5x plus 2y equals 20. X is equal to 4. 1.5 times 4 is 6. Divide by 2, y equals 7. So your solution for this system is 4, 7. That means that is the solution for the top equation and the bottom for the entire collection of equations. Now it also means that if you were to graph these two lines, it intersects at 4, 7. Let's look at number 4. 3x minus 6y equals 12. 4x minus 8y equals 16. Does not matter, whichever one you want to cancel out. I'm going to cancel out the x this time. So I look at 3 and 4. The number they both go into is 12. Alright, so I'm going to multiply the top by 4 to get a positive 12. I'm going to multiply the bottom one by negative 3. That gives me 12x minus 24y equals 48. Gives me negative 12x plus 24y equals negative 48. Well, this cancels out, this cancels out. Everything cancels out that side, so you're left with 0. This also cancels out 0. So you got 0 equals 0. The variable's gone, everything. So in this situation, it's either no solution or all real numbers. Since this is true, that means all real numbers, which you would put down infinitely many solutions. That means it's infinitely many solutions to this system. It also means that if you were to simplify these down, like take a 3 and take a 4 out, it's going to give you essentially the same line. So it's infinitely many solutions, all real numbers. Alright. Next, number 5 is a mixture problem. We're going to talk about mixture. This is what we're going to do in chapter 1, but I just have to go out for now. So let's read this. You need to know how to do mixture problems. This is a manufacturer of soft drink advertises their orange soda as naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure, let's play a part, orange juice must the manufacturer add to 900 gallons of orange soda to conform to the new regulation? Well, guys, what I always do when I have mixture problems is I draw some canisters to help me visualize it. Okay. So you're mixing two things to get this other one. Alright, so it says a manufacturer soft drink advertises orange sodas, so it contains 5% orange juice. So the basic problem is saying how much pure am I going to mix with this 5% to produce 10%? So go in order of your percents in the problem. 5% comes first, so I'm going to put 5% here. 5% plus the pure to get the 10%. I know in the end I want the 10%. But if something is pure, guys, that means that's 100% orange juice. So you're going to put 100% here. Change it to decimal, move this 2 places, that would be 0.05. Move this 2 places, that's 1. And this is 0.1. Now the 5% went with the orange soda. It says how much pure orange juice? I don't know that. That's not pure, so I'm going to put an X right here. Must be added to 900 gallons of orange soda. That's the 5%, so I'm going to put 900 here. Now, what am I going to put here? So this is my percentage right here. This is how much quantity I have. I don't know how much pure orange juice. I know that I'm going to add it to 900 gallons of orange soda. So what could I put here? I want you to think about that a minute. I have 900x. What could I put there? I'm hoping you would put 900 plus x. 900 plus x. Okay? Because if I have this 900, I don't know this, I can just write it as 900 plus x. Now, what do I do now? Bring this straight down and multiply this times this. 0.05 times 900 plus 1 times x is x. Equals this times this, and then just solve the equation. So 0.05 times 900, that is 45 plus x equals 0.1 times 900, 90 plus 0.1x. Solve the equation. So 45 plus 0.9x equals 90. 0.9x equals 45. 45 divided by 0.9. X equals 50. So, must add, this needs to be 50. How much pure orange juice must be mixed with 900 gallons? Would be 50 gallons. Okay? you need to pause it right there, you can. Okay. On the back, you notice their systems get a little bit bigger. The ones on the front were easy ones that you've been doing since Algebra 1. These we started doing last year with 3 variables. 3. We're going to solve them those by elimination as well. We're going to do 1, 2, and 3. Alright. So this is on page 2. I'm going to write this number 1. Let it focus in. I'm sorry. I'm going to write this number 1 on notebook paper so I can have more room. X minus 2y plus z equals 15. 2x plus 3y minus z equals 7. 4x plus 10y minus 5z equals negative 3. Okay? Alright. So what you do first is look at the first 2 equations. First and second. And you have to determine which variable you want to cancel out. What is screaming to me right now is the z's. You got a positive z and a negative z. That would be the easy one. So I'm going to bring those over here. Make sure you copy everything down correctly. These z's cancel out. I'm left with 3x plus y equals 22. Alright, now I'm going to take the middle and bottom. Now, if I cancel the z's out on the first go around, I've got to cancel z's out on the bottom too. So here we go. 2x plus 3y minus z equals 7. 4x plus 10y minus 5z equals negative 3. Okay, so I look here. Cancel z's out first, so I cancel z's out in the middle and bottom. Well, if this is negative 5z, what does it need to be right sitting right here? Positive 5z. So I'm going to multiply the top one by negative 5. That gives me negative 10x minus 15y plus 5z equals negative 35. X plus 10y minus 5z equals negative 3. Remember, when you multiply negative 5, you multiply everything. These cancel out. I'm left with negative 6x minus 5y equals negative 38. Now, once you get it down to 2 variables, either x and y here, x and y here, you take this equation and this equation, and you try canceling out and eliminating another variable. Okay? Here, you could go with either x or y, does not matter. I'm just going to go with x. If this is negative 6x, this needs to be 6x. I'm going to multiply this by 2. Negative 3y equals 6. I'm going to divide both sides by negative 3. Y equals negative 2. Alright. So, I know y value. I got to go back and find x and z, so I'm going to work backwards. If y is equal to negative 2, I go back to one of these original, not the manipulated. One of these I just used to find x, if I know y equals negative 2. So I'm going to choose this top one. 3x plus y equals 22. Substitute negative 2 in for y. X equals 8. Now that I know x and y, go back to one of my original. I'm going to choose the first one. X is 8. My Y is negative 2. That's going to give me a positive 4. Z equals 3. So how do you write your answer? You write it as an ordered pair, but it's not called an ordered pair here because you got this called an ordered triple because you got 3 numbers. So it would be 8 is your X value, Y is negative 2, Z is 3. So that is your answer, 8, negative 2, and 3. It's not called an ordered pair, it's called an ordered triple. Put in alphabetical order, X, Y, and Z. You can pause the video at this time if you need to review any of that. Basic recap. You take the first 2 and decide what variable you're going to eliminate. Get it down to 2 variables. Then go back to the middle and the last one. Eliminate the same variable. So that gave us to these 2. Then you had to eliminate a variable, got down to 1, and then work backwards, plug one into one of these, and then one into this. Alright, let's look at number 2. We have X minus 3Z equals 7. 2X plus Y minus 2Z equals 11. Negative X minus 2Y plus 2Z equals 6. Okay, this one's a little easier because look at this first one. The bottom 2, the middle and the end both have 3, but the top one only has 2, so they did some of the work for you. They already eliminated the Y in this one, so you don't have to do anything with this first one, but this bottom 2 says this Y is missing up here. You need to eliminate the Y. Need to eliminate the Y. So I'm going to come over here. 2X plus Y minus 2Z equals 11. Negative X minus 2Y plus 2Z equals 6. Well, if this is negative 2, this needs to be positive 2, so I'm going to multiply this by 2. X plus 2Y minus 4Z equals 22. Negative X minus 2Y plus 2Z equals 6. So I'm left with 3X minus 2Z equals 28. Now that I got this down to 2 variables, equals 28, if you can't see that. I take this one and this one. X minus 3Z equals 7. 3X minus 2Z equals 28. To me, the X is the easiest to eliminate. If this is 3, that needs to be negative 3. So I'm going to multiply this by negative 3. Negative 3X plus 9Z equals negative 21. Bring this over. That leaves 7Z equals 7. Z equals 1. Now that Z equals 1, I'm going to go back to one of these that just had 2 variables. I'm going to choose this one. X minus 3Z equals 7. Plug 1 in for Z. X equals 10. Now that I know X and Z, go back to one of the original. I had all 3 in there. I'm going to choose the middle one. 2X plus Y minus 2Z equals 11. Plug 10 in for X. I'm looking for Y. Plug 1 in for Z. Gives me 20 plus Y minus 2 equals 11. Where 20 and negative 2 gives you Y plus 18 equals 11, Y equals negative 7. So your order triple will be X comes first 10, Y is second, and Z is last. 10, negative 7, and 1. Okay? If you need to pause it, you can pause it now to look at it closely. Number 3. The last one. X minus y plus 5z equals negative 2. 2x plus y plus 4z equals 2. 2x plus 4y minus 2z equals 8. So look at the top two. You want to eliminate a variable. It looks like the easiest would be y. So come over here. Eliminate. X, 2x give you 3x. 5z and 4z gives you 9z. Negative 2 and 2 gives you 0. Now if I eliminate y's on the first two, you're going to eliminate y's on the middle line. So now I'm going to come down here. 2x plus y plus 4z equals 2. 2x plus 4y minus 2z equals 8. If these y's need to eliminate, if I have 4 here, what do I need here? I hope you're thinking negative 4 because that's correct. I'm going to multiply this by negative 4. Negative 4 times 2 is negative 8x minus 4y minus 16z equals negative 8. Y's cancel out. You're left with negative 6x minus 18z equals 0. Okay, now we're down to these two last two. We're almost done. Okay, I'm going to bring these equations down. 3x plus 9z equals 0. Negative 6x minus 18z equals 0. Make a determination if you want to eliminate the x or z's. I'm going to go with z's. If this is negative 18, this needs to be positive 18. So I'm going to multiply by 2. Watch what happens here. Boom, boom. All that cancels out, left you 0. Boom, that cancels out. 0 equal to 0. All your variables cancel out. Is that a true statement? Yes, it is. So, is your answer no solution or infinitely many? It is infinitely many. Okay. Alright, so your assignment that goes along with this lesson is page 11 in your notes, numbers 1 through 15. Have those completed by Monday. Thank you.